Hi, I'm Dion from CertMathsVideos.com. Now this question asks us to prove if a is equal to 13, to prove that fx is greater than 0. So we just rewrite this, so 1 over x squared minus 6x plus 13. Now when we're asked to prove a lot of questions like this, if something is greater than 0, we always have to remember to try and get a term in brackets, because then we know that, or bracket squares, because we know that squared is greater than 0. So we see this here, we can actually change this. We have x squared minus 6x. So then we could actually look at that as in x squared minus 6x, maybe plus 9. So we'll just try that. The reason I chose plus 9 is because then we can factorize the bottom term, then we push plus 4 here. So then, this is fx. So then that is equal to 1 all over x minus 3 all to be squared plus 4. And since that is positive, that implies fx is always going to be positive. Because any real number squared is positive. And then in the second part of the question, we're asked to prove if a is equal to 13, that f of x is less than 1. So 1 over x squared minus 6x plus 13. 6x plus 13. We're asked to prove this is less than 1. Well, again, I'm going to separate this into a term we can get squared, so that's x minus 3 all to be squared plus 4. Now, this is f of x. Now we're asked to show that this is less than 1. So basically, if the denominator is greater than 1, that means that the whole result is going to be less than 1. So all you have to prove that the denominator is greater than 1. So that we have to prove that x minus 3 all to be squared plus 4 is greater than 1. So you're greater than 1. And that's definitely true. Straight away we can see that's true. Because 4 plus a positive number is always going to be greater than 1. So that's really all you have to write for that question. And on the third part of the question, we're saying find a range of values of a such that f of x is greater than 0 and less than 1. So we'll just write out the equation one more time. 1 all over x squared minus 6x plus a. Now it has to be greater than 0, remember that. We start off with greater than 0 first, and then we'll go from less than 1. So if it's greater than 0, we had, when a was equal to 9, we just write a equal to 9. 1 all over x minus 3 all to be squared. So that implies that your f of x is going to be greater than 0, because no matter any real number squared is always going to be greater than 0. So f of x is going to be greater than 0. But say if we had a equal to 8, well that's the exact same as 1 over x minus 3 all to be squared minus 1. So basically it's x squared minus 6x plus 8. So we're just rewriting 8 as plus 9 minus 1. So this is x equal to 8. And then we have 1 over x minus 3 all to the square plus 1. But if we had x here equal to 3, that means we have 1 over negative 1, which means our fx is going to be negative. So that means that x is going to have to be 9 or greater for it to be greater than 0. So x is greater than or equal to 9. That's to make sure that x is greater than 0. Now to make sure that x is less than 1, we have 1 all over x squared minus 6x plus a. Now to make sure that fx is greater than 1, remember just looking back from the part of the other question, this part here had to be greater than 1. So if xs is less than 1, this denominator here has to be greater than 1. So that has to be greater than 1. So we have to find the values for a for which this satisfies f of x to be greater than 1. So x squared minus 6x plus alpha to be greater than 1. So that is x squared minus 6x plus, let a equal to 9 for now is greater than 1. So that implies x minus 3 all to be squared is greater than 1. Now that is not true, because as you see, if x was 0, it wouldn't be. So we'll go on one more time, we'll try 10. So x squared minus 6x plus 9 plus 1 is greater than 1. Then we have x minus 3 all to be squared is, the ones will cancel each other out, just subtract 1 from both sides, is greater than 0. But that is not true. That maybe is true, but when x is 0, it's not true. So that implies that it's only true when x is greater than 9. So when x is equal to 9, or when your alpha is equal to 9, we will get a point where it's equal to 0, not greater than 0. So any value for alpha greater, 10. For any value of alpha greater than 10, that will satisfy the conditions of it being underneath 1. So to satisfy the conditions of it being underneath 0 means alpha has to be greater than 9. And to satisfy the conditions of fx being less than 1, that means alpha has to be greater than 10. So really, alpha is going to have to be greater than 10. It's not greater than or equal to now, it's greater than 10. Because if it's greater than or equal to, then we know that this would be wrong here. So it's alpha greater than 10.